Welcome to this webinar about the application for wind power forecasting developed during the EVEREST project. I'm Matteo Grasso from Duferco Energia, and I would like to introduce the methods implemented and the main results achieved. The application has been designed and developed from scratch after an analysis of the state of the art and exploit the potential offered by the EVEREST environment. The energy prediction use case considers two logical steps. The first one is to generate local weather forecasting using the WRF model. And the second one is to use artificial intelligence methodologies in order to predict energy production based on the local datasets of wind energy farms. The challenges are mainly related with these two steps. Actually, Duferco Energia is buying this kind of service from a market leader provider, identified as the reference provider to compare the forecast accuracy. To train the machine learning model, we collected 2 years of high-resolution WRF data at different height levels and observation time series of several wind farms covering the same period, mainly hourly generation data. The choice of the machine learning algorithm in the first phase fell on kernel region regression, because it is suitable to start training with a low quantity of data. And also it is easier to configure the hyperparameters. The training strategy selected consists in using the data related to the period till the previous day, and then to forecast the day ahead. This process is repeated each day, increasing the training dataset by 1 day. Finally, to evaluate the accuracy, we selected the most suitable KPI for wind power forecasting according to the literature. The wind farms for the backtesting analysis were selected in consideration of the amount of available data and on the results obtained by the reference provider. During this analysis, it was clear the high impact of input data quality on the forecast accuracy. The quality of the weather forecast, and in particular of the wind speed, is the cornerstone on which the accuracy of the forecast rests. So, eliminating wind forecast data that was inconsistent with the final generation data allowed us to maintain good quality of the dataset for model training. To do this, we introduce a physical model based on the power curve of the wind turbine, which is technical data provided by the turbine manufacturer. We also implemented smoothing methods to improve the profiles by smoothing the spikes both on the input and also on the output data. The daily workflow of the application can be split in 3 main steps. The first is related to WRF weather prediction for the day ahead, closing at the beginning of the day D. Then there is the pre-processing step, with the selection of WRF data for the wind farm coordinates and height. The pre-processing is based on observation data with the power curve method, and finally, but not least, the anomaly detection module. This module is developed by USI inside the EVEREST project. Implements machine learning algorithm to detect and discard bad samples. And the third and last step exploits the cleaned dataset to train the machine learning algorithm. And finally, to predict the hourly generation of the day ahead, based on the WRF prediction of the same day. The entire application was deployed on Carolina IT4i supercomputer. It is possible to manually execute the workflow on IT4i Lexis platform too. To do this, you need to upload the observation input file, like in this slide. The name is observation example for ML. In this slide, we can see the observation file that we need to upload. And to be more specific, this is actually the file that we used, in our case, an Excel file that is named Observation Calabria. So once the upload of the observation file is done, you need to select the workflow from the workflow menu and to create a new workflow execution. In our case, we need to select the ML at IT4I workflow and then execute a new one. In this slide, we simply show an examples of the previous execution of our workflow. And then here we created a new execution. It is required the name of the new run and also to indicate the input path of the observation data. For the other values, you can leave the default values. In this slide, we can see the execution run that we created on the 31st of May, of course related to the EVEREST IT4I ML workflow. It can be possible to monitor the status of the run. So in this case, we can see that our execution is on status running at the moment. And on Lexis, we can also see the advance of the entire workflow execution and see in which point of the pipeline we are, let's say, at the moment. Okay, now we are talking about the results. This is a snapshot of a backtested week for the Calabria wind farm. You can see in green the curve of the hourly generation, in red the kernel reach forecast produced by the application, and finally in blue the provider forecast, which is, as we also said before, the benchmark identified as a market leader. We can see that the two predictions have similar shapes, and also similar errors, we can say. The metric used to evaluate the forecast accuracy is the mean absolute error normalized by the wind turbine installed capacity. In these final slides, we would like to show two different example days. The first one, where the reference provider performs better, as we can see. Our normalized mean absolute error, 17%, is higher than the reference provider. And also another example in which the kernel ridge performs better respect to the reference provider. And this is the shapes, and we have a normalized mean absolute error below the reference provider. Finally, we would like to thank all the partners of the EVEREST project for their kind cooperation, and also thanks you for the attention.